addressing the students here, and specifically the students that just arrived on campus, the first-year students in the grad program, and maybe those who in some way haven't been exposed to this building during the time that it's been under construction or during the design process. But this is a special place, and this is a kind of story. It's a kind of building. It's the kind of process. Everything about this building is what all of you as students should look forward to, because it really represents kind of the best of what our profession can do and can offer, really, to the world. Really to start, it represents an enormous vision and commitment that Georgia Tech made to do what they knew would be a very difficult building. This is not, it might just look like a normal building to a lot of you, but as you'll hear throughout the Joe's talk and the other participants, this is a very sophisticated building. And I think what's really important as one of the many lessons that it offers is that it represents also a kind of attitude and sensibility that all of you should have about the impact that the built environment has on the climate. And this building literally is a regenerative building. It's a net positive building. So that's what it literally does as a building, as a small part, of all the buildings that make up Atlanta and make up, the country. But I would also argue that it operates at a symbolic level, which means a lot. In other words, this building, it's really the kind of talk of the city. I would say it's a talk of the country. I mean, when I've been traveling around in different states, people are talking about this building. It's a prototype, and it's becoming a kind of an example of what an enlightened client, an enlightened design team, and a group of people can do to really make a difference. And so, spend time here. This is going to be a great lecture. You're going to learn a lot about this building during this lecture, but spend time here. It's not that far from the architecture building, and there's a lot to learn about this building and about what this building represents as it plays out over time. So I want to introduce Joe. Joe Greco is the president of Aeck Sargent. Aeck Sargent is the lead design team on the project, working with Miller Hall Partnership, and a whole team of consultants, which you will hear about. And again, Joe, when we first started talking about this lecture, he immediately said, I can't really give this talk alone, because it's in the very kind of DNA of the living building, and certainly the process that they implemented, that this was an extremely collaborative team effort. And there's another lesson for you students, and you will hear after Joe's talk, when he's talking with all of the consultants, some of the consultants that worked on this, how teams work together to pull off something like this. So Joe really wanted this to be not just a lecture, but a kind of almost a telling of a journey of what this building is about. And so after his talk, he'll be joined up here by three of the key players on the team. Jim Case from Uzen & Case, who was a structural engineer. Todd Lewinsky, who from Newton & Boyd, mechanical, electrical plumbing engineer. And somebody from Skanska, whose name I forget.
Matt Williams.
I don't know, I can't do that. Matt from Skanska, and I have to say, the several times that I came over here during construction and took tours, I mean, it was just amazing how Skanska was running this project. And I can assume from your end, it was complicated because you were just trying to get the building built, and everybody kept wanting to come through and see the building, so you were probably playing kind of tour guide as much as you were trying to build this building. So, yeah, it's an understatement, right? But Skanska did an amazing job. And then also be joined by Alyssa.
Alyssa.
Okay. I have all this written down. I usually don't. Okay, Alyssa Kingsley, who was a project architect on the project. How are you doing? Good. You gave me a tour, in fact. Okay. So before I hand it over to Joe, I also want to mention Michael Gamble. Michael Gamble is going to moderate the panel discussion at the end, but I also want to acknowledge just what Michael, the role that he's played in this project. Literally back before it was even, probably in the initial conception of the project, Michael has been kind of an ambassador for this project. He supported it. And he has not only, I think, played a key role in getting this project to realize, but he's also been a tremendous ambassador to the College of Design and the School of Architecture, keeping us involved in this project. None of you will know this, but in 2016, I think, when the competition for this was going on and the teams were coming up with design ideas, we ran a studio in our graduate program, the Portman Studio, where all of the students in that year kind of mirrored the design competition and designed their own kind of version of the building. They kind of shadowed the teams that were working on it. They engaged with Georgia Tech. It was a tremendous learning experience for our students. And this building has been a kind of case study for many of our courses over the last 3 or 4 years, and Michael has really made all that happen. So kudos to you, Michael, for your ongoing support of this building and representing the College of Design. And I also want to mention Sean Aurora, if Sean is here. Did he leave already? Or he's worried about how many people are here. He was counting the number of people to make sure we're not over capacity. And we only were 18 under, so we can bring 18 more people in. Anyway, Sean has been so generous in getting us in here, really kind of before the building's open. But he's been really helpful in making this happen. So I'll shut up and hand it over to Joe Greco. Joe.
Great. Can everybody hear okay? Great. All right. Thank you, Scott. Well, I have to say this is about as exciting as it gets. I'm a proud alum of Georgia Tech, and to be able to come back some 35-ish years later and to be here in front of you guys in a project that I think is going to be as important as this is I'm very proud of that, and it's frankly very exciting. I think the talk is really, see if I can get this to work right. The talk is really going to be kind of, as Scott described, the journey of how we got here. It's a little bit different than most projects that you come across where maybe design is kind of thought of as driving everything. This is really a marriage of design and analytics in the most kind of iterative, integrated fashion you can imagine. To do a building that performs this well is not the stroke of one pen. It really requires a lot of iterative thought where you make a move, you see what it looks like, you see what it feels like, you see how it performs, and you go back and forth kind of an infinite number of times, as it were. So it's a pretty neat thing, and I think this will hopefully will kind of give you a little bit of insight into how that process worked, and certainly we'll touch on a couple topics that maybe will be you can answer in a little more, ask a little more detail during the panel discussion. I think one of the things that's most interesting is that this is a true partnership project from the beginning. The Kendeda Fund is really the lead primary donor for the project. Georgia Institute of Technology is providing the land through the state, but also it's going to be a big part of the mission of the project going forward in terms of being able to educate students and hopefully change things in the future. The whole project was set up around the Living Building Challenge, and I'll be touching on that in a little bit, but it's a program that's been established. Everybody's probably heard of LEED and some other green programs out there to sort of foster and promote sustainability. The Living Building Challenge really takes that to a whole new level. It says, don't make buildings less bad, make them actually good, make them net positive in every respect. And it is a challenge, hence the name, as you'll see through the project process. I think, I guess the other thing is, why would we want to do this project, or why did Georgia Tech and the Kendeda Fund want to do this project? part of this was to try to advance ecological design in the Southeast, where it's particularly challenging, and to really have this as a case study that other architects, other contractors, other designers, people will see it and maybe get a little something from it, and it'll have sort of a more lasting effect than the building itself. Really sort of to create those kind of best ecological practices. We really wanted a building that would have regenerative spaces, the kinds of spaces that make you feel good, feel positive, do great things. I think this auditorium is actually a pretty good example. It's got natural light and you can see the screen, and I think at this point everybody's still comfortable temperature-wise. It's really about creating a healthy and beautiful environment, not to the disadvantage of the other, but really both. Another reason that we should be taking this pretty seriously, atmospheric carbon is at a level never before seen. So guys, it's all time for us to do something here. The Living Building Challenge, this is sort of a metaphor of the flower, but it's made up of 7 petals, and this was going to be, from the day one, was going to be a fully certified Living Building Challenge project. 7 petals, 20 imperatives. You've got to do everything. There's no sort of pick and choose. It's really kind of an all or nothing thing. So with that one guidepost that was immovable, the team sort of set forward on this crazy journey. Hang on one sec. I don't know if anybody, I'm sure some people are aware of it, but the project originally started out as kind of an invited competition. There was really an earlier RFQ, and then an RFP, but it came down to 3 selected firms. We were one of 3 teams that went after the project on this journey. We're the Aeck Sargent Miller Hull Partnership team. All the teams actually put forth incredible ideas, and it wasn't a design competition for buildings, really an ideas competition with the thought that any good idea that came out of one camp or another camp could actually be shared, talked about, and brought forward in a positive way. This was really about trying to do what was best for the project, for the campus, for Kendeda, for the world going forward. So it was a pretty unusually altruistic sort of a set of circumstances here. These are a couple images from the charrettes in our office. They were fairly intense. I think there were 2 all-day, 8-hour events where Georgia Tech sent several representatives and really wanted to see how the team worked together. Again, it was an ideas competition. This wasn't about what exact building design would come out of this. And they wanted to see, Georgia Tech wanted to see how the team was functioning together, how we interacted with the client and with each other to try to create the best possible project down the road. This was kind of our team's mantra in a way. It's an Albert Einstein quote, and obviously he does have some special talent, but I think the real point is that it's his curiosity to learn more and to not come in with fixed ideas was what really drove our team. We really felt that having that open-mindedness was going to be critical to creating something special. And given that we, unlike Albert Einstein or math challenge, we were determined that somehow we would make 1 + 1 be greater than 2, as in working together and unlocking and creating overlapping synergies. We would make more out of it than the sum of its parts. The site that we're all sitting in, and you probably won't recognize it very well, except you can see sort of the original Tech Tower complex there in the corner, is roughly where the green circle is. This used to be a pretty agrarian landscape. In fact, there was a creek that ran, frankly, right through, not the middle of the building, but really just down the hill there. The very first thing we did was to try to understand the site, and working with our landscape architect. You can see how much the site has changed. It was again, had the valley in a way that kind of went through it. It was residential at most in scale. It was agrarian before that. The site dramatically changed. There's the orange line is the 1928 contours through the parking lot, and there's the 2016. So it's basically, the hole's been filled in. There's a pipe underground. It's no longer the native landscape, and really there isn't really a very good reason to try to completely return to its native conditions, but to try to simulate what some of those characteristics were so that it's a more ecological solution. Just kind of getting a handle on the site, we did a before and after section. We really, the genesis of the design came out really of thinking about the larger eco-commons idea, which was the larger space that will soon be under construction. But as you move your way through the site, you can see the sectional lines changing. The amount of fill is, frankly, pretty astounding. As you work your way further and further on, the right-hand side of the site gets closer to sort of native grades. Keep moving in that direction. And as you get sort of close to the site, there's actually generally native soils at this point. And I think what's important is that you see these spectacular trees out there. They would only be existing in the native soils, both from a growth point of view and from their longevity. Those were pretty important design drivers for the project. We looked at the basic sort of site hydrology. Historically, you can see the blue lines, essentially the creek that would be running beneath, and then overlaid that with the Boulder Georgia Tech vision for the eco-commons. That's in fact a green belt that works its way all the way through the campus, and this portion of it is kind of the missing tooth at the moment that kind of connects back behind the president's house, but a really sort of spectacular landscape idea that this building would have an opportunity to really reinforce if designed properly. Just a quick analysis of the site. That's the existing tree zone that really needed to not be disturbed, and we worked very hard to do that, and essentially tried to locate the building in what were previously disturbed areas. And then, of course, the parking lot is the future eco-commons. We looked at a lot of different site ideas during the competition. We had 5 sites, I think, at our first touch point meeting. But behind that, there were, and that's probably half of them, there were a lot of other ideas as to where you could put the building and what it does in terms of how it embraces the eco-commons lawn. We did a lot of sort of noodling and doodling, as architects are wont to do, with a couple different design ideas that might apply to different sites, but really kind of began to try to explore what were some of the potential opportunities in the broader site. We actually weren't given this site specifically. It was really take a look at the entire eco-commons lawn and find the right place. The master plan actually did have the building roughly located on the site, but we were asked to say, hey, take a fresh look at it and see what makes the most sense. Finally, as we thought about it, we came back to really trying to use the Living Building Challenge pedal system as a little bit of a sort of a permanent guidepost to help inform the decision-making process, to keep us asking the right questions. And I think one of them is how does this building authentically located here in Georgia? How is it grounded to its place and time, and how it will be respectful of the past, but also kind of create an environment for new thought in the future. Man, my font got messed up. All right. So anyway, porches are one of the things in the South that you often think of these big, huge sort of mansions with porches, but they're also incredibly functional, and you find them even on the most utilitarian shed imaginable. We also kind of got fascinated with sort of the dog trot, the idea of being able to pass underneath a building that sort of creates more light, more opportunity for ventilation, more connection. And then finally, the trees. I mean, if you haven't just walked out there, they are spectacular. These are some of the best trees on the entire campus, and they are, in a way, they become a part of the architecture. Those were some of the key driving forces. So we set about coming up with a couple of different schemes. We first were going to try 3, then eventually we said, all we can really accomplish is 2 different ideas for the ideas competition. We did feel like it was very important to come in with not one idea, not one solution, but really to think about it a couple different ways to see what those 2 design paths might unlock in the way of opportunity. So this is the bridge trot scheme. We combined the dog trot and the bridge. I don't think that's a really great word, but it's what we had. Just some of the sort of inspirational images, but the idea that you would sort of be able to pass between and underneath and connect the building. Basically, it would straddle what is the former Dalney Street corridor and have its a strong connection out onto the future eco-commons. That's sort of the site diagram there. Gives you a sense as to how we were thinking about it, just in the most pure sense. Very, very early in the process, we knew this was a landscape-driven project on many fronts. It is going to be connected to one of the signature green spaces, really rivaling the tech green on the campus, and the building did not need to be dictating to the landscape. It really needed to be a seamless connection. So we started pretty early imagining how the building would front and connect and filter through to the future eco-commons, which hadn't even yet been designed at the time. And this is sort of a more developed landscape plan for that scheme, but the idea that you can work your way up in a universal design that's available for everybody at a gentle slope and be able to engage the building as you work your way up sort of from the pedestrian movements, both east and west and north-south on this site. To do this, we kind of took the program blocks, as you guys probably do in studio class, and really just tried to allocate them on the site in a way that made sense. Built up a scheme, and this basically was the framework for the dog trot, bridge trot scheme, but where you really kind of engage the building by passing underneath it. It lands on the eco-common side, and you can get into it sort of from this highly active center spot. As I mentioned, the analytics are pretty important, so all these couldn't be half-baked ideas that didn't have a solution for actually achieving the kinds of energy goals needed. We did pretty serious work on trying to figure out how you would condition the building. Even came up with, on this particular scheme, a pretty innovative idea to use a downdraft chimney to filter the pollen out of the air so that the building, while it's nice temperatures outside, maybe high pollen season, if you could do that, there might be a way to sort of more naturally ventilate the building. Really explored a lot of different concepts. Some of these kind of made their way into the final design. And then we did an energy analysis. PAE is our consulting engineer, along with Newcomb and Board, and essentially ran the energy analysis model. That's an EUI number, which is, why am I forgetting it? Energy use intensity. But anyway, that's a really high-performing building, 26. You could see a baseline would be 66. This would be a very high-use building. So it would, there's plenty of buildings that are actually well in excess of that. So the target was to try to get to a building that would be really, really low on energy, because the Living Building Challenge requires you to generate more power than you use. So if that number is high, you can imagine the size of your photovoltaic panels goes out into the parking lot, which probably won't work for anybody. We also had to look at some pretty serious wastewater treatment strategies in order to have an idea as to how this would work. You have to be net positive water, meaning you can't put more, you basically have to recycle the water that falls on the site, and you can't essentially discharge anything primarily to the city sewer system. So it has to be handled at the building and site level individually. And then I think, at the sort of most important design level, which I lost my screen, we really wanted to look at how you would integrate that architecturally into the design so that it has a story. It teaches as you go through the building. You understand the technologies at work, and they have an architectural implication. So the thought of this building, I think part of its mission was to be a building that actually teaches in the way it's constructed and the way it's designed. So that was a big part of the driver. And these are just a few of the renderings, but again, very sort of open social space, not highly unlike the atrium that you see there, and but a different engagement. It's an engagement that goes underneath the building and sort of instead of beside the building was the way we sort of saw this scheme. So that was the bridge trot, and this is the porch. So another dilapidated porch. I think one of the things that is most interesting about porches is that they're very occupiable. You can actually theoretically have classes out there, and I think we will probably see a lot of uses that get done that way because of the availability of outdoor space. It's not that you have to teach everything inside. You've got roof terraces, and you've got other sort of opportunities to expand that teaching window. And just again, a few more diagrams as to the way we sort of thought about the program working on the site. The nanotechnology building, which is a pretty stunning building in its own right, but unfortunately the loading dock sort of backs up to this side of the building, so it became clear to us as a diagram we didn't really want that to be the front door of the building. There's also sort of the noise issue of the mechanical system. So the way we conceived the building was there was a little bit of a solid bar closest to that side, and you actually sort of came between the two bars as you came in. The other, I think, interesting aspect is, again, you've got the Dalney Street pedestrian connection. It was a road when the project started, but the master plan had it going to a pedestrian type connection exclusively. And there's also, if you notice, there's sort of a nice natural berm of trees out there. So we saw that as an opportunity to help kind of define the porch space. It also has some trees in it, and it has the opportunity to plant additional trees for shading in that west direction. There's sort of the diagram. Normally you try not to have a big west-facing porch. That's sort of probably the last idea you'd want to have when you're trying to do a climate-responsive building. But in this case, given the site and the location of the Eco Commons, we felt that it was actually overrode the simple analytical aspects of that. In order to do that, though, we had to do some pretty incredible things in the way of having a porch that's out there a good 30, 40 feet. It's the photovoltaic panels, so everything on the project does two things. You have panels up there, they're generating electricity, but they're also shading the porch and shading the spaces for people to inhabit. Between it and the trees, we were able to we felt, get a pretty good solution. That's our wraparound porch idea with the big porch on the west was actually pretty doable. And I think, frankly, our team liked the challenge that posed. Similarly, we worked on the landscape to really think about how the building interfaced with the landscape. We ultimately became clear that we didn't actually have to follow the exact Dalney Street road bed, so that became a much more sort of amorphic shape in the final design. You can see it sort of moving in this direction a little bit through the early landscape ideas. And we built up a program with the sort of student atrium space in the middle. Again, it's changed a good bit, but in a lot of ways the idea has pretty well remained intact. Had to come up with good systems there. You can see the big porch. I think at that point we were actually looking at kind of a shading system potentially out on the edge, both in the plane of the glass or further out. And in the end, by changing some of the material of the upper level, we were able to get to a spot where we didn't actually need that. And then we did our energy analysis. If you remember, basically, at this sort of preliminary level, they performed pretty similarly, both at the sort of 26 EUI. Ultimately, the building is, once we got into more of the program details, we'll find that it's a little bit higher number. But what we determined was that neither scheme should be picked simply on the merits of being a higher performer than the other, that they were both basically in the ballpark. So that wasn't a design driver or selection driver. Wastewater treatment ideas, and then again, same idea, trying to really make all the educational aspects, all the technical aspects of the project very visible. A few interior renderings, and then the rendering that we shared at the end of the presentation. So we were selected, which was a huge day. We were incredibly happy. There was a lot of hooting and hollering around the office, but it was an exciting time, and we were pumped to be able to embark on this next level of the journey. The team, as I think was mentioned, Aeck Sargent Miller Hull partnership essentially became tied at the hip as the architect for the project. Miller Hull is in Seattle. Newcomb and Boyd and PAE had a similar relationship. I think PAE is in Portland and maybe a couple other locations, but they worked hand in hand with Newcomb and Boyd. Andrew Pogon is the landscape architect working with Biohabitats, who's a specialist on the water treatment around the building. And then Usen and Case, Jim Case is here, is structural engineering, and Long was the civil engineer for the project. There were some other folks, other team members that got added later, but this was the core team that went forward. Here you can see everybody that was on it, and it is an overwhelming number of experts that wound up working on this project. Everything from sort of biophilia experts and facilitators. We had some innovative code, life safety work done on the project. Skanska joined the team as a construction manager, but the nature of this project, there was a lot of things that were in their sort of design camp from a design build point of view. So I think they absolutely belong up here as part of the design team. And then we needed to stay within the cost parameters. So there was design associated with that too. And this is kind of the group, and I'm sure I have left off some people, but it was a pretty big group of people that had meaningful roles on the project. I'll point out a couple in addition to the panel that has been identified. Joshua Gassman in the upper left corner, he PM'd the project for us and really led the day-to-day effort and probably took most of the arrows. And then Brian Court from Miller Hull Partnership was the lead design out there. But it really was a tremendous team effort, and I would say every single person up there had an important voice at some point during the course of the project. So we had the two schemes. We were selected. We came back and met with Georgia Tech, and they said, well, they're both interesting, but we like this one a lot better. So we started in that basic direction, kind of with now a real program. There was kind of a straw man program when we initially began, but this was sort of get serious time. We actually led the programming effort, but we had more information to kind of go on at that point, and really kind of went serious about trying to develop a design that could be built. We jumped back in and looked at the site. It's right at that slope where it's almost impossible to solve, but it is quite possible, where you can come up without any railings to get in there. And we felt it was really, really important if we were going to be connected to that landscape idea, the eco-commons lawn, that it has to be a seamless, comfortable connection. So that drove a lot of the specifics about what floor level you are at, and the sort of immediate connection to the outside was, ended up being one of the other big drivers. See a little bit of the landscape, and again, just that point about really connecting to the landscape all the way through the building, I think was one of the big drivers of the big design drivers, sort of from an aesthetic, but also kind of a philosophical, that strong connection to nature, that there's a inside and outside component to learning and really to being a citizen. This is may seem kind of wacky. One of the strange sort of requirements of the Living Building Challenge is you've actually got to have some form of edible agriculture on the project. It's different at different scales depending on what type of project it is. And we looked at a number of different alternatives for accomplishing that imperative. It's part of the site pedal. We kind of came to the conclusion that all of the intensive agriculture ones that would be larger just didn't make sense in this kind of environment. We explored them pretty seriously. You could kind of do it off-site in a scale jumping fashion. You could do it in different ways, but ultimately in the end, we felt like the edible landscape was a more sensitive, more appropriate solution that we evaluated on kind of a pass-fail gradation scale. And really came to the conclusion that this is the one that fit the cost model, didn't cost a lot extra. It was interactive. People could forage with it. It was supported the honey production on the roof, and it was one that could sort of seamlessly integrate in the project. So ultimately we went down this path, but it was one thing that we had to determine early on because it has so many impact on the site calculations. Water is one of the big drivers. It's a real challenge. Water in the southeast is a huge problem. We maybe not be in a big drought now, but there's been years where it's a huge, serious situation in Atlanta. I think generally is felt that that's probably the biggest impeder to growth in the Atlanta region. So handling this responsibly, I think, was one of the things that was really, really critical for our team. As one understands it, in a pre-development, essentially, water falls, it lands on the ground, it percolates in. If it's a really heavy rain, some of it spills off and works its way into the creeks. But that's sort of how that would normally be in a virgin landscape. Standard practice is if you build stuff, you've paved it, you've got roofs, and now you got to stick it into a storm sewer and basically pipe it all over the place. It's not particularly efficient. It's not particularly ecologically friendly. It doesn't recharge the groundwater. There's a lot of things that aren't super good about it, but it is sort of standard practice in most urban environments. A living building says, we're not doing it that way. You got to use the water in more of a circle of life, as it were. It has its absolute use back in the daily consumption of the water. You don't use the city water as a municipal source, you use the rainwater. I think the other piece that's important is that it says you do need to infiltrate it on site, you do need to recharge the groundwater, And it's only in the sort of the most extreme rain events do you actually end up with any significant surface runoff. So to do that, you really got to give it a lot of thought. The hydrology is key, and Andrew Pogon, our landscape architect, is fantastic at that. They're also fantastic in understanding how do you interface the site circulation with that hydrology so that it has a human sort of connection to it and is beautiful in the end. The planting is our big part of that, and the way they thought about that was you really have kind of the shedding woodland zones, you've got the seepage wetlands, and then you have the newly planted edible landscape. Where all those things come together, you kind of create a mini ecotone, which is where the greatest plant diversity is. So thinking about that as a quilt that comes together at the ground plane and at the roof level was, I think, one of the most spectacular things about the project. So you can't get all of the impact now because you don't see the eco-commons there, but when that comes in, I think this building will seem just incredibly grounded in its landscape. The other, sort of big kicker there with water is you can't use the sewer system in a living building. It's not permitted. So you have two choices. You either essentially have a miniature wastewater treatment plant, which is the Blackwater solution, or you do a composting toilet scenario. If you note, the potable water needs are really the same either way. It's just that if you go with the toilet flushing, where you've captured all your rainwater and are using that for flushing, you have a much larger amount of water you've got to be able to treat. In the end, we went with the composting toilets. I don't know if anybody has availed themselves to them, but they're pretty cool. It was a lot less expensive, and it had a much smaller footprint, and in the end, it was by far the best choice. So it was one of the ones that I won't say was a no-brainer. We went through the exercise, but it's the one that sort of made the most sense. I think just trying to explain the water systems, there's really essentially three kinds of different sources. There's the Greywater, which is the water that comes out of the sink. We want to capture that. We're not going to drink it again in this scenario, but we do want to be able to use it for irrigation, for subsurface infiltration, so that you're not just sort of dumping it into the sewer. There's plenty of plants that could use that water. The rainwater is collected for potable use, or it will be. There's a valve that we still have to switch once we get the final city approvals, but it will essentially be rainwater becomes your drinking water. And then also the mechanical system does have a small amount of condensate, and to be able to sort of use that effectively as part of your site irrigation was another idea. So you're not wasting any of the water. You're putting good use to everything. The rainwater capture essentially works off the PV canopies as well as the green roof. So there's gutters that funnel that into a filtration system. And then occasionally when you get a heavy rain, or if the cistern is full, which it probably will be most of the time, you've got to find a way to use the infiltration as your stormwater, so that you, again, get good use out of that. It feeds the plants, and it's part of sort of a natural ecological solution. These are a couple of drawings, but I think the main point there is these don't have to be, these aren't underground pipes. These are site amenities. You see them. You see the water flowing through the site. You can put benches by them. It's actually like a miniature park that runs along the edge. So really thinking about them from a design point of view, not just a purely functional point of view, is what I think Andrew Pogon did such a good job with, and helped us sort of really come at the building from a landscape perspective. That's a view back looking in the other direction, but again, very tied, very integrated into the site. And really taking that all the way into the plantings in an elegant way that makes for a nice human experience. So when you walk out there, there's indigenous plants, there's appropriate plants, and they keep, in effect, help keep the area cool and green and much more pleasant to be around. I'm showing these renderings. The building changed a little bit since then, but the focus really isn't on the building. It's actually on the landscape. These renderings take the actual plant species that are out there in order to try to visualize it. And I guess the point is, it's not just green in the sort of generic sense, but there's a lot of thought that went into what kinds of spaces does the landscape help inform and create. So we tried to look at what it actually looked like too, in addition to how did it perform. So that was a view under the porch. This is at the south entrance, which is still being worked on, but there's a major point there, is that as soon as you walk in the front door, you get something that says to you, this building is different, we're handling things in a different way, and it immediately sets the tone for the experience. The universal design, again, trying to make the building accessible for all different levels, for different people, is an important part of the living building ethos. And then the roof terrace, again, sort of behind you, and again, the design on that changed a little bit, but I think the main point is that you've got the ability for connection from the upper level to the lower level, and that there's sort of this strong visual and plant kind of relationship between the two that's, feeds the soul in some way. So energy. That's fun. That's Todd's big area there. How will it respond? How will the project respond to the climate now and in the future? We have an idea what it's like now. We do know that it may be worse in the future. So we are hopefully we have a little cushion built into it, and so hopefully we'll be good if temperatures rise a little bit. But I'm hoping that all of us architects in the room could do something to keep that from happening, or certainly happening as quickly. This was sort of the latest energy use intensity model. I think we came out around 34 and a half, somewhere around there in the end. But it really required sort of a detailed look at what are the various pieces of equipment in the building that are going to drive those energy loads. You'll notice just the plugs where people plug stuff in are pretty big numbers. So a lot of that is user dependent. We set about, as I mentioned, thinking about the building program. This is what we worked on with Georgia Tech to really kind of nail down what was going to be in the project. But in this project, we also looked at what do those spaces mean from a thermal point of view, so that every space isn't treated identically thermally. There are some spaces that are allowed to float in different temperature ranges, and some that are more tightly controlled. And we wanted to sort of locate them in such a way that it makes the most sense, so that they're co-located if they're of a like use. The yellow book, and that's not going to mean anything to any of these students here, but Georgia Tech has a big, thick yellow book. And this is the operating manuals for how buildings are supposed to be at Georgia Tech. And it's pretty constraining, and it's pretty specific. And there's a really simple, it's a painfully simple equation to get there. But we decided to try to dumb it down for us main architects, and to use a strategy that's called adaptive comfort, instead of just trying to be in a narrow humidity and temperature zone. But if you look at humidity, the clothing anticipated airspeed, you've got the large fans in here, the temperatures, what is the radiant temperature if you're near the sun, or you have something warm on your feet. It all changes how you feel in terms of your comfort level. And at the end of the day, nobody really cares if the building is 68 or 72 or whatever it is. They care if they're generally comfortable, and I think that's the thing that matters the most. Our strategy was to take what would have been the narrow band of the yellow zone and expand the comfort zone using all these other tools, so that the building could use a much broader range of available mechanical systems, some that are much, much more efficient than a standard one. And in the end, and this is a pretty interesting tool that's out there available, but it allows you to understand, if you can play with any of those variables, how do you find the comfort spot by changing any of those sort of factors. And you can actually, it's a little bit different than the sort of standard kind of plug and chug with a mechanical system, but this is taking a much more holistic look at what comfort means. And this is a tool that really architects can use if they want, in sort of trying to sort of set up the basic parameters of a building. We looked at a number of different systems, and you don't need to go into a ton of detail. This one has a really, really innovative one, in that the floors in every room but this one are heated and cooled. So there's hot and cold water that will be pumped through there. It's a much more passive system, so you're only supplying a small amount of ventilation air. Very, very different than these huge ducts that you see in a lot of buildings. It's really a very, very low energy use, and it hasn't been done very, very often in the Southeast. It's more of a Northwest type strategy, or a northern strategy. Looked at some other ones, but in the end, this was the one that met the cost parameters and seemed to be most in keeping with the Living Building Challenge sort of ethos as well. One of the interesting things, we originally had started the project, we were going to reject the heat in a geothermal solution to the ground. In the end, we wound up doing it to the campus loop, which exists, but we have to do it in such a way that we're net positive. So we're actually helping the campus energy by rejecting and borrowing heat and cool over the course of the year, where we actually are a net positive contributor to the campus loop. And it's very comfortable on the floor. Had somebody do that at the opening house. I think that's Rachel. And health and happiness. You know, this is one of the sort of touchy-feely parts of the LBC, and I think a lot of it is trying to get people to think about things differently. You know, how do you make full use of the building? How do you capture every usable space? And how do you create healthy environments that are, I guess, evocative, they're inspirational, and they're technically sound, and create healthy environments. One of the things that's really important is the quality of the light. So, you know, we really studied the daylighting solution very, very hard in the atrium. There was a time when the project was a little over budget, which is apt to happen. And one of them was, well, you could save X number of dollars by taking out the skylights. And we went through the exercise that said, you know, that's really changes the quality of the space out there. You'll have lights on even though they're efficient. It's just not the same human experience. So we wound up, you know, kind of coming to a positive middle ground on that I think, you know, when you look at the space and the quality of the light and the evenness of the light, I think it was a very, the dollar is very, very well spent in the end, but we needed to do the analysis in order to really kind of prove that to everybody and to ourselves. Just sort of, you know, giving everybody a little lay of the land. These are the floor plans, and I think there's some design here that's important in terms of the way it works for humans to interact and to foster collaboration. So we essentially have this sort of student atrium space there in the middle where you come into the building and you get to see all the different activities. There's a makerspace off one side. There's sort of student informal lounging areas and the collaboration spaces as you work your way down the steps. The core is sort of tucked in, part of that solid wall that's facing the nanotechnology there. And then, of course, this auditorium is there right at the end, kind of at the end of the vista, so you're able to see all the way through when the garage doors rolled up. I think the other piece is there is actually direct exterior connections here. So in the nice months, you'll be able to expand those inside spaces directly to the outside. So kind of, in a way, expanding the footprint, the academic footprint. The upstairs, again, there's the large atrium space and then access onto the big green roof, which is really a spectacular space up there as well. The two main large classrooms are upstairs, and again, there's a sort of a student atrium space in the middle, so there's a lot of opportunity to bump into colleagues. Since it's a multidisciplinary building, it you know, again, helps sort of foster that sort of idea exchange. That was, again, a big part of the design drivers. That's the PV array. You can see how large it is. There's the green footprint underneath, but that's how much photovoltaics we needed to get to be 5% positive on the project, which is the requirement. We may have shot for 10. 5 to 10. And then finally, the basement level. It's fairly unusual, but most buildings close off the basement. Ours is intentionally open. It's part of the tour, in a way. So when people come in to try to understand the building, we wanted it to be a pleasant journey downstairs, and we wanted it to really show something, and that it wasn't hidden and completely out of sight, but it's part of the story when people come to try to understand how the building works. It's a beautiful basement there, Matt, by the way. So health and happiness. Health, I guess, also includes, are you safe in the building? And we had to do some interesting analyses along these lines. There's two ways to think about it. You can use the prescriptive life safety methods, which is, this is what the code says is what you got to do. We wouldn't be able to actually do that atrium exactly as is. We'd have had to have smoke exhaust, or we'd have had a lot of other exits. So the strategy we used was to show that through a simulation model that the performance would actually be better than if you closed in the hole. So the analysis is, okay, you fill in the hole and you add a stair, and that would be the alternative. So in the numeric analysis over there, blue is good. It means you can see, you're not on fire, and the smoke isn't real bad. So when you actually compare the two, the performance is significantly better than the prescriptive. So we were able to talk with the life safety official, and they agreed that this was a better solution than what the code would tell you to do. So it was a way to get what was a much better social space and to do it technically and properly, so that we all knew what we were doing, and it was, in fact, a safe environment. We had the biophilic design workshop. I don't know if anybody knows what biophilia is, but it's essentially taking nature-inspired forms and working them into the building so that it has a stronger human connection to nature, and it does tend to make people feel better. So it's one of the requirements of the LBCs to actually have that workshop so that you begin to start thinking about things in that fashion. I don't think there isn't, you don't need X number of biophilic elements or anything like that. It's more of a mindset. And we went through that process. I think it was pretty beneficial in terms of how we thought about things. It's just sort of a little sampling of the materials, and I think you can define biophilia in many different ways, but I think this does give a fairly good sense as to what that means. We used a real honesty of the materials so that when they were, brick, which is a recycled brick, or wood, you had the sense of what the material was and that it's a natural one. There's salvaged slate in that tile up there. The PV canopies are a lot like tree leaves that are up there, so there's sort of this sensibility and sensitivity to nature. And finally, that brings us to the materials. So in a living building, you can't put a bunch of certain chemicals that are really bad for you in them, and that's just the rule. You can't have it. So you got to do a lot of research to make sure that you're not doing that. I'm not even sure what most of those things are, but they're probably not good for you. There's also sort of a movement out there that LBC is putting out, which is really about trying to make manufacturers more transparent about what's in their materials. And we were fortunately able to find a lot of the ones that meet this declare label. This is kind of like the nutrition label for building products, and we're hoping that as more and more of these projects get done, that becomes a sort of a more and more of an ethos out there in the marketplace. Jumping over to structure, which is a super cool one. So if you look up, you can get a pretty good sense. This is considered a mass timber building. It is, there's different kinds of mass timber. This one happens to be a nail laminated timber. So those thick boards where you see the up and down above the beams, those are actually nailed together, and they're done off-site and then sort of brought here as a panel system. We did first, before we went down that path, did an analysis and said, well, it could be wood, it could be steel, it could be concrete, with probably some elements being steel anyway. We tried to do a thorough analysis on what are the benefits. In the end, we felt like wood was one we really wanted to explore, and part of it was the sort of embodied carbon story. It's actually, while concrete and steel essentially put carbon in the atmosphere, the wood buildings, when you grow the trees, actually sequester it. So it's a negative in that regard, even if you add in the some of the steel that you did need for structural reasons. So from that point of view, it's a really powerful choice, and I think we'll see a lot more of that kind of construction out there. Plus, in Georgia, it makes a lot of sense. It's the number one sort of industry relative to agriculture in Georgia, and it grounds the building in a way in its place, because that's important locally. It's important to the local economy. So why not try to showcase that? And ultimately, we came to the conclusion that it was the best choice. Steel has a lower carbon footprint than concrete does. There's a lot of recycled, and in the end, we wound up using some steel in order to try to enhance the performance of the wood. So if you'll note when you go out there, or even in here, there's steel pieces that are relatively small, so they're essentially working as the bottom part of that truss, and we're able to keep the wood members a lot smaller, so they're much more efficient members that use a small amount of steel. So in a way, we felt it was the best of both worlds, and it kept the building light and airy from a design point of view. Now we're getting into Matt's world over here. So it's not exactly designed, but it's kind of designed when you get into it. In the end, the building has to be net positive waste. You can't. Everything has to be calculated, and it has to be done in such a way that you're not just dumping a bunch of stuff into the landfill as you might on a typical job site. There's actually an incredible number of recycled products that are in the building, and I'll show just a couple of them. But the tile that you see in the bathrooms is a combination of a tile that has a specific ecological upside to it, but it's mixed in with salvaged slate from the roof on campus there. The curbs have been repurposed from other locations, so they've been moved here and used out in front. The tech tower, actually, some joists that were, I guess, during a renovation or a rework, they were salvaged, and we wound up using those for the planks on the stairs there. So they're all the wood treads. So a pretty neat story with that. And then the whole log benches that you see are pretty incredible, and they're from sort of felled trees that had happened, in the vicinity. So we were able to kind of capture that and repurpose it. And then one of the biggest ones is there's a tremendous, I think everybody knows the movie industry is huge in Georgia, and there's always a lot of kind of movie set waste that goes out of this. We were able to salvage it and repurpose it with the help of the Life Cycle Building Center to create the structure above. So if you look up again, every other board, the ones that are recessed are junk. They're salvage board that have no structural, no calculated structural properties. The ones below are the only ones that are needed for structure. So in a way, you kind of created that structure, that enclosure for half the structural cost. And there's a great story of that stuff not ending up in a landfill. Which brings us, weirdly enough, to equity, because all of these things are tied together in the living building. It's a circle, like a flower. The panels were actually put together through a program with Georgia Works. Skanska, participated with this, but it really trained a lot of folks who didn't have skills with new skills, new construction skills, to learn how to do some of these kinds of things. And it was done, in a warehouse off-site, but it was an outreach program as part of equity to try for the project to try to do something good besides itself, but to really affect some of the people in the community in a positive way. There's another picture of it. So beauty, well, that's always in the eye of the beholder, as they say. I don't think there's anything that gives you a beauty checkbox exactly, but we think the project is pretty inspirational. We certainly think it helps teach people. These were some of the renderings that we sort of generated, and to kind of get a feel of what it looks like, and with some photographs following it up. Again, some of those collaborative spaces. I think it came out pretty similarly to that, so we were all generally pleasantly surprised every time the building got a little more cleaned up when we walked in. And certainly seeing it used has been tremendous. Just a little bit of the design evolution. As everybody knows, as you work on a project, you begin to make minor adjustments or sometimes major adjustments along the way that respond to either new criteria or to budget or whatever it happens to be. But you try to keep the design concept intact. So we worked really hard to do that. And again, while it changed a good bit, I think it still captured the spirit of their original idea. There's an earlier version with the canopy and how we essentially finished most of the design phase, and that's how it came out. So with that, I guess we'll head to the panel part. But thank you for the opportunity, and great. Crank up your HVAC a little bit, man.
Respect.
A little bit.
That's great, Chase. You did good job.
Thank you. Huh? Yeah, maybe so. Oh, I think you're right. The sun came down on me. It was in the shade to start with.
Okay, so I'll need you guys, except for you, to pass pass the mic back and forth as you answer. And that's all.
You can do that.
Okay, well, I'm going to give my age away here, but I don't know about some of the older folks in the room,
Sorry.
but I was educated by a lot of smart people in some of the worst classrooms in the world. Windowless auditoriums, windowless classrooms, furniture that off-gas. I mean, I made it. I learned my way through it. But I think what we're seeing in this building, the Club Commons, and a few other buildings is a big sea change in the type of environments that we learn in. So I want to make that point to begin with. And the other, couple of other points to reiterate, Joe mentioned it, but this is imagined as a non-denominational building, meaning that it doesn't belong to a school or a college on campus, and that it's really conceived of as a highly equitable place where people with similar ideas about preservation and ecology and design can meet. The Kendeda Building for Innovative Sustainable Design. That's really, really super important. And equity is a big part of that. So I really want to reiterate that. And interestingly, Georgia Tech has been planning for a building like this for a long time. And I think Howard's here. I see John at the back, John and Kanye. There's a whole group of people at Georgia Tech who aren't on the academic and research side, who have contributed to the creation of a really inspirational campus. And many of you, again, I'm giving away my age, you don't remember when just about every surface on campus was a parking lot. All around the College of Design, Inman, the center of campus, even outside of Club, that was parking. And it's taken 10 or 15 years to get to the point to where we could actually, through our infrastructure and through planning for a future, prepare for a building like this on campus. So I want to give a lot of credit to Georgia Tech's leadership over the years who made Tech Square happen, for example. These things have to be imagined first. We're talking a lot about imagination in our studio. These spaces have to be imagined and executed. Georgia Tech, progress and service. Our challenge is to imagine a world that's more humane. That's something that we all sign up for here at Georgia Tech. Progress and service. So our challenge is to improve the human condition, and design plays a major, major role in that. And I'm looking at so many young faces out here. That's the, this is the group we're trying to reach the most. We're trying to lead here. And finally, the Kendeda Building for Innovative Sustainable Design is about community building. So there's community building happening on campus, but this is a place where all of these different sectors can come together and overlap. So believe it or not, next semester there's going to be calculus taught in this space. Why would we teach calculus in here? Because students who may never come into contact with a building.
Make calculus more fun.
It's a big class.
I think I had it in Howie.
There's chemical engineering courses being offered. All the lab spaces, the instructors are retooling the experiments to be more energy conservative. So just you're going to hear a lot about that as we go along. So I want to ask just a couple of questions to the panel to get the conversation flowing, and then I want to turn it over to the audience. I mean, we have all drank the punch, let's face it. I mean, we are pretty familiar with the building and we subscribe to it. But I want to make room for questions. But the first question, and I'd like to start with Alyssa, would be more about how a project like this would begin to change the culture in the office, or the culture of practice, right? Because I think I've heard a lot of excitement around a project like this coming to Lord Aeck Sargent. And you and I have gotten to be friends through the process of this. You and Scott brought a little one into the world during the process. It's been really interesting. But what are some of the ways in which a project like this might impact professional practice for, let's say, an architect approaching mid-career?
Well, we were friends before you picked me first. That's a great question. I think I was about 10 years into my career when I started on this project. No offense, Joe, but I was a little downtrodden on the work that I was working on. And when the opportunity came up to work on this project, I asked everybody to be on this project. I went above Joe and I went to Tony Aeck and I said, I want to be on this project. And I think that was a change in culture, to be, you know, we like to play it cool, and you know, it's not very often. That's the other side of the story. Nobody else was doing. I was fighting for a position that nobody else had. And not because it wasn't a great project, but because we were busy. There was a lot going on, and so that was kind of a change in culture for me to speak up a little bit more in the office, to find my own voice. And then once on the team, we had this not so great team philosophy of saying, you know, throw out any stupid ideas. I change it to that no ideas. Not everybody can say what they want. And so I think team-wise, it changed the dynamic of the way we talked about things, and we came up with a lot of creative solutions by making it an open and collaborative process. And then office-wide, I think people saw, having this project in-house, people saw this as an opportunity that, you know, to rethink the way they talk about their own projects and reconsider how we pursue things. And I think since then we have been approached about numerous projects that have similar sustainability goals. We just recently won a project where we'll see what happens, but the client said, I want my project to be more sustainable than the Kendeda Building. And that's one of the great things about being a superlative when you say that a building like this is going to be one of the most sustainable buildings in the Southeast, is that somebody says, well, I want to do one more. And so it's getting the culture of the city and other building owners to change the way they talk about buildings.
That's awesome. And I'd like to ask the same question to Matt, because I think that Skanska has been really proactive in promoting smart building practices, working collaboratively with architects and design teams to see a project like this to fruition. But what's particularly interesting is the way in which Skanska has reached out to the community to elevate the workforce, job training, et cetera. And I'm wondering if you could speak just a little more directly about Skanska's role in community development.
Well, kind of like one of the goals of the project, one of the exciting things is let's talk about this job was coming to the Southeast. We have a lot of experience with it in the Northwest. Those areas that do a lot more living buildings and a lot more green building in general. And so it's exciting to be a part of this job and to come here. But the equity investment and the title that came up with our involvement, including Georgia Works, and just trying to reach out, and we kind of stumbled into that relationship when we had budget issues to try to find a way to save money when people didn't want to break routine and habits and use salvage 2x4s in the NLT construction. So we did that, and we kind of took a leap of faith that we could do it, and we could do it. We just weren't quite sure how much it would cost. To build all these, and that kind of stumbled us into needing that workforce development, because we don't have a lot of hourly people that would kind of work their tools or more construction management. So in doing that, we had to go out and find those people, and we had relationships previously with Georgia Works, and they had a great story, and they were willing and just wanted to be a part of it. So they brought some guys in. They worked wonderfully. The guys, one of them particularly, stayed on for almost the entire construction of all the panels. We had 489 panels that we built because we needed to. We had a couple extra built because we had to. But he was a part of almost all of those. And then he took that experience and that work ethic that he learned and developed with us and was hired on full time instead of a part-time employment hourly type of work. So he used it to better himself. He kind of better us because he was a great guy to be around. And so I think that was a worthwhile endeavor, and we were excited to be a part of that.
That's awesome. So for Todd and Jim, a question related to the status quo. Is this the future, or is this the exception when it comes to how you would see design and building practice in the next 5 or 10 years?
I hope it's the future. The one thing you might find is surprising about engineers, but sometimes we're sort of by the book and straight and narrow and kind of do what we're told. And so a building like this really forces a lot of engineers outside their comfort zone and to think about maybe not designing for every possible scenario, and maybe having some flexibility where things might be a little bit not quite the same as normal. So it's been a big learning curve for me, and I think what's happening around our office, and I hope is going to, we can help populate this thought, is that as engineers, we can really help drive things and push things and show people what are possible. You know, as those crazy ideas get thrown up on the board, like, hey, can we put a big hole in the roof and let hot, humid air come in during the spring and then use water to somehow flush out that pollen? Yeah. My mind almost exploded that day. It turns out, not really, but it was a fun thought exercise for us, and you know, a normal project, that's not even something that would kind of get on the table. So, like I said, I hope that there are more opportunities for this, and I hope that, you know, engineers, all sorts of engineers can help sort of lead that effort instead of just sort of waiting for somebody to say, hey, we need better performance.
Well, this building was kind of a dream come true for us. You know, we want to do things that integrate architecture and engineering and actually all the disciplines. And we want the opportunity to do our work in the most creative and interesting way possible. So it was an extension of our culture. But you know, when people think about engineers as not being creative as they should be in some senses, I don't think it's really true. We really feel like our responsibility is to deliver value to society, okay? And so we're very much thinking about cost when we make decisions. And we feel like that's our responsibility. That's sort of our moral responsibility in a way to carry that through. You know, it's more than that, right? Society is a larger thing. And I think what this process did, it was meant to be an ideas competition. It was meant to stimulate people into thinking in a different way. And I think it really did that. So when I think about my practice as an engineer, about the people who work for me, now it's not immoral to think about making a building that might cost a few more dollars a square foot because it's solved a social need. You know, there are people who say that if we built all of our mid-rise buildings out of wood in this manner, that we would reverse the buildup of carbon dioxide in the atmosphere by that one act. And so what it does is it frees engineers up to think in a little bit different manner than they might have been able to do in the past.
That's awesome. That's great. A question related to, I guess it's status quo related in a way, but I go back to the data question because I was a little bit surprised by the title. Of course, there's a lot of data in the way in which the building is generated. But is there, and this is for Joe, is there such a thing as too much data? I mean,
I would say no, there's not. It's not too much data, but it is the ability to filter out the noise so that you look at the essential data and decide which ones take precedence. But if you don't have the data, you can't sort of make that value judgment. So, I mean, I guess you could, in theory, dump so much data that you can't ferret through it. But if you're the one generating it, the notion is you want to generate what could be pertinent. You weigh it against the design, maybe the softer, more subjective design aspects, and then you try to make a decision that best triangulates and really creates the best value holistically within that group.
it's certainly, it's something we're trying to instill in our educational model here as we tend to be inundated with data sometimes, but I really like your suggestion that you have to sort of know how to manage it, and you have to make decisions along the way to determine what's really useful. Otherwise, you just sort of drown it.
If you just use just the data, we probably wouldn't have the west-facing porch, which is the sort of seminal idea of this particular scheme. And I think in the end we were able to find a way to mitigate those downsides and create the special connection to the eco commons and make that possible.
That's great. This will be my last question, and this is sort of a free-for-all for any of you, and then I'll turn it over to the audience. But does a project like this, from a practice perspective, or from a construction perspective, engineering perspective, collaborative perspective, does this change the risk model for design practice? And if it does, I mean, how is the risk changed? I mean, we're making a big promise here that the building is actually going to perform in a way and be monitored in a way over a 12-month period. And I'm really curious, as a design professional, what, if any, impact that has on the way you all think about your businesses?
I guess. Is that you? I'll do what? Yeah, sure. Yeah. No, I'll do it. So, I mean, every project's risky from a different point of view. There's certain uncertainties in this that are associated with the full building certification. But every building we do has to stand up. It has to perform. And frankly, with the quality of the team members and the seriousness of Georgia Tech as a client in challenging the design team, I'd say that this one is in some ways less risky because there's so many eyes on the road. So I hope that doesn't bite me, but yeah.
And I also think you have to think, what is the risk of not innovating?
Yes.
So the safest thing to do is what's been done before, right? And unless we do this, we're not going to learn anything. And then whenever you do something innovative, there's a possibility that something untoward is going to happen. And it's a risk that you have to accept. But once this becomes more of a model for other things, it'll become the tried and true method, and the risk will be low again. So, yeah, right.
Matt, you want to comment on that?
In terms of the constructability and all that, I don't think that was a big risk for us. It was more the administrative burden that we found to be the risk. The red list, as we had up on the screen, that I had nightmares of the red list. It was a big administrative burden that the more of these that happens, the greater the database of products that we're able to use, and the more transparent companies that provide those products to us are to us, and the expediency with which they give that information will tremendously help us on these as they go forward.
That's awesome. It reminds me of one of the first meetings that we had internally with John DeConge and Howard and Steve. There were a whole number of people, and like the red list was right at the top of the discussion, because vetting toxic materials takes an enormous amount of time, and it takes incredible willingness on behalf of industry. So, the carpet in here, in a way, it sort of started with carpet through the Ray Anderson folks at Interface, and it's building momentum. It's actually building a lot of momentum. So that's it's quite good. Any other comments on the risk issue?
I would just say, whenever we work on a project like this, we lose money. So, there's an investment, but it's an investment in something that's going to pay off in the future. So there's certain kinds of risk, but I think all of us would probably say that that this wasn't our most profitable project.
It's funny, the red list too reminds me when I walked in. I don't know if Brian Bell is still here, but Brian said, "Smell that new building smell." There he is, right there, and it smells like wood. Right? You don't smell like linoleum or adhesive or paint. Like so many times you walk in a new building and the first impression is paint. Right? That's what overpowers you. That was a good one, Brian. All right, well, as I promised, I'm going to turn it over to the audience. If there's any questions, I think that Carmen would like for me to pass the microphone around. And I see I've got two here. We're going to start over here, and I'll come back to Sean. Just introduce yourself real quick, too.
Hi, I'm Liz York, and I'm from the Centers for Disease Control and Prevention. So my challenge or question for you guys, and it is a hot seat question, how are you going to take the lessons that you learned from this project to your next client and help us be more innovative?
That's a tough one. I guess you have to have a client who at least is interested in hearing that. So assuming that is the start point, I think the easiest way is to give tangible benefits and some of them can be positives and some can be, hey, we tried this and it actually didn't turn out to be as good an idea. But to show what worked and to show maybe also that it was cost effective and that it was the right solution and it's worth going off the beaten path a little bit. I think it's an easier sell to be able to actually point to something that's built and not theoretical, but it's actually doable. And hey, we can go take a look at it and see what you think. So that'd be my answer.
I think there were a lot, also to piggyback on Joe's, that there were a lot of jurisdictional challenges with this project. He mentioned the life safety performance review. We also went through a really rigorous water permitting process. The structure, the permitting process was a little interesting, not because we had to do a special process, but we kind of went forward and backward in time with technology to make this building work. And so adaptive thermal comfort is not necessarily a new technology. We instituted new technologies, but it's something that we did. We worked with on Hardman Farms, which is over 100 years old. NLT is a mass timber system, but it is not a new mass timber system, and so it's not having the same issues that CLT or something else will have with going through the code review process. It's also been around for over 100 years. And so there's this jurisdictional understanding and code understanding that we now have that we can bring to our clients and say, we've made this work. We found a way to put this building together, and we can use it as a case study when trying to permit new buildings.
Zach, I think the next question was right here. This is Zach Brown, by the way.
Thank you. My name is Ardis Bishtat. I'm a faculty member in the School of Building Construction here. I have 3 questions. So the first question is about the cost of the building. So I assume that the initial cost was or is higher than the initial cost of other buildings that are not positive energy buildings. But I assume that you have conducted also a life cycle cost analysis. So I wanted to see how the cost, the initial cost, and also the life cycle cost of Kendeda is compared to another building that is not a zero energy building. The second question is about what are the barriers that you see that prevent you or that make you not want to do this kind of project again. And then the third question is about...
We only get 2.
I only get 2, okay. All right. The third question is about the collaborative process, the strategies and the technologies that you use in this project that you find it beneficial and that was unique to this project that you didn't use or that you didn't have such experience in other projects. So these are the 2 questions. Thank you.
Okay, we have to restate the questions. That's my job. Maybe we work backwards. What about the third question? Or the second question? Let's start with the cost question.
That was the first question.
That was the first question. All right, the first question, cost. Life cycle analysis. What about this issue of cost? It's come up a few times. There's pretty solid responses to that question. I'd like to hear from you guys.
Well, I'll do a quick overview on it, and I'm sure there's folks in the audience that might be able to do a deeper dive. But one of the basic tenets of the project from Kendeda and Georgia Tech was that this project had to be replicable, meaning it doesn't have to actually look like this, it doesn't have to be the same thing, but some of the processes, it has to be essentially achievable in some form going forward. So I won't say that the cost is not a little bit more than some other ones, but to be fair, it is expensive to build buildings on the Georgia Tech campus because they're built at extremely high levels of quality. So you're not using sort of a generic cost starting point. I think the cost of the project might be, I don't know, 15 or 20%. There may be some premium depending on how you look at it. But if you think about the life cycle, that you're not going to pay a power bill on the building. It's pretty huge. So I think the building's a little bit more, and maybe I'm wrong. Maybe it's spot on, but it's fairly close to what it costs on the institutional market. And I think in terms of could there be most aspects parlayed into another institutional grade project on any other campus, I think mission accomplished. Absolutely, it can be.
Me personally, I don't have the life cycle cost information going forward. I can tell you that one of the challenges we ran into as we started this journey 3 or some odd years ago, we were at the beginning of a big ramp up of the market in the area. And so a job this size, it was tough to get a lot of the quality contractors you want to want to bite off on a unique and never been done, and once they kind of did a little bit of homework, they kind of saw what they were getting themselves into. And Howard, I have nightmares at the cost of cubic yard of concrete. All our conversations on that. So those items it kind of went into it. It may have added to the cost of this project, just a function of the size and the way that subcontractors can bite off and gain production on this. As you look around, it's unique everywhere you look. So it makes it beautiful, but it makes it a little bit harder to get people to want to price it. So.
I have actually one thing to add. One of the more enlightened presentations that I've seen in the last couple of years is the appraisal industry. Building appraisers at the commercial level who are trying to put a value on these sorts of life cycle technologies. And interestingly, if you're a building owner, and there may be a few in the room, if you own the building and you're paying the energy and water bill every month for your tenants, that comes off the top. That comes off the top of the value of the building. So you have a gross operating income, you subtract all of the expenses, that's your net operating income, and then for anybody who's got a finance focus in here, you run a cap rate or you do a comp or whatever. And the less energy a building uses over time is added value. And we're waiting for the appraisers to catch up, but it's happening. It's coming from both directions. Georgia's not initiating the discourse. It's frankly started on the West Coast, but it's happening. Okay, the other question was?
Technology and integrating processes that was unique to this project?
Yeah. Technology and process integration.
Oh, yeah, go ahead.
I don't know that we really used anything out of the ordinary from a technology perspective on this project. I mean, there were software tools that maybe don't get used often, but I think we used just the normal tools we use in our daily business. Having sort of a West Coast team and an East Coast team required a lot of online conference calls, but we're all really well versed in that. I think Howard at one point thought we might have 2 shifts of like an East Coast team working on it and a West Coast team working on it. That never really materialized that way, but
Too slack. That'll save you money.
But anyways, no, I think the teamwork of just having this unique goal to kind of bind us together, and we were all headed towards that one goal. That's really what brought the team together and led to success.
The thing I would say about it was this was very well run as a collaborative process. And so it makes it joyful for the consultants, it makes it joyful for the people working with the consultants, et cetera. But one of the keys to working effectively with consultants is to get their input at an early point in the job. And just like the schematic design is what establishes the cost of a project more than any other phase, the schematic design of a structure or a mechanical system is highly dependent upon what you do. So I know like our ideas about the columns in front of the building, which were sort of molecular and meant to be related to the campus, were ideas that came up in the charrette or in the selection process. They weren't ideas that were generated. And if they weren't generated at that point in time, we might have thought, well, this is going to be a wood building and we're going to have wooden columns and we just need to make them big enough, So I think engaging engineers in this process early is a good thing to do. And when you think about it, as culture develops, as we become more computerized, as engineers, day-to-day calculation work becomes less significant. What we have to offer are our ideas and creativity at the beginning of the project. And I think maybe this Kendeda funded effort here is helping design culture to evolve in that sense.
Hi, thank you all for coming and doing this talk. My name is Tasha Snedeker and I'm with the master's program first year here for architecture. Oh, master's of architecture, obviously. And my question is, because the Kendeda Building follows the Living Building Challenge, was there more coordination between the teams? Was it more complicated, or was it just kind of like same old, but now we're working on a living building instead of a lead building instead of a regular commercial topic?
I'll just take a first shot at that. No, I mean it is not like designing, the greenest lead building you can find. It requires a much higher degree of timely collaboration and the importance of each and every decision early in the process. There's such a cascading effect. If you get one of those early decisions wrong, it's you create a hole that you can't really dig your way back out of. So I think it fosters that collaborative spirit out of necessity right in the beginning. And I do think that just the general respect level of all the consultants have for one another and the specific area of expertise they bring to a particular problem made it very, very comfortable for the team to know when to go and to go early. And Melissa mentioned there's the no stupid questions, or there aren't any. Takes some of the pressure off of sounding ignorant on something. So I think it was that kind of environment where you could ask anything to anybody at any time.
I'll add on real quick that from my perspective, in particular on the energy side of things, there was no decision that we made practically that didn't impact the energy use of the building. At one point we were having conversations about espresso versus hot brew coffee versus cold brew coffee. And you might have seen, if you had an eagle eye on the energy chart, the coffee cart was listed on there and its little bar was as big as the makerspace. So, and that's using hot coffee, not espresso. So it was a really interesting process to have to think about every little detail down to that level. And like I said, other than things like colors, those kind of decisions, everything was really kind of factoring into, we have this energy budget that we have to get under. And, if something went up over here, then we had to take something down over there.
All right, so let's, we're going to take one more question and call it a presentation, because we're all going to spend a lot of time in here in the next 10, 15, 20 years. And I see a couple of hands up over here, over there, wherever. Dean French gets the last word.
Thanks. Steve French. So, we talked a lot about the team effort here, and you all look like pretty seasoned professionals, and you've been through this really crucible of a intense team, 3-year project where you've been forced to work together. how can we train our students to be ready to be team members when they graduate? What can we do to give them the skills where they can jump into this kind of team environment and not have to get there by OJT?
I think the most important thing is to ask questions. Don't be afraid to ask questions. Never be afraid to ask questions. We're afraid when you don't ask questions. I think to be prepared to be part of a team is whether you fully feel it, believe it or not, is to act like it. And so you got to kind of put that fear behind you getting into it and embrace all of it 100% from the beginning.
Yeah, I'd agree. I think being passionately curious actually is a pretty good starting point. Obviously having skills, having good design skills, having analytical skills, being able to learn, being in the process of learning how to make high quality value judgments, but being excited, being interested, being curious about learning more, and then again being able to work in that team environment. Nobody here knows everything about any of these things. It really took everybody to do that. So you've got to realize it's okay to not know something or to necessarily have the answer to it, to be willing to ask the question and being willing to engage and make the whole team better. That's what we look for in interns when they join the office.
So I'll give a controversial answer to that. I think Georgia Tech does a really good job in teaching people to work in a team manner. It's gotten better and better over time. We hire a lot of Georgia Tech students, particularly the architecture program. I think does a good job because it's a team sport. But one of the problems is being a part-time teacher here is that unless you have the base technical knowledge, you can't be an effective collaborator. So in a sense, teaching somebody their base technical skill is the best team skill that you can teach somebody.
Me personally, I think to be in a good team, you need to be open and honest, and you kind of need to check your feelings at the door, because especially the guys here, they like to push. Just because you say the auditorium should be directed one way doesn't mean the auditorium will end up being that way. So there's a lot of that give and take, and it goes all the way around. Owner, architect, client, consultants, we all kind of jumped into that head first, and I think we still generally like each other. So.
That's good. Well, that's a great way to end today's presentation. I want to thank everyone for coming, especially our distinguished group of engineers and collaborators. And I think there's some refreshments out in the central space, and we look forward to hosting many, many more events in here and teaching as well. So thank you.